Now, after finished firing, we want our weapon to slowly move downwards back to the original rotation, right? And we can, just to demonstrate, I'm gonna use set control rotation just to show you that you can either use add controller input or set control rotation. It shouldn't matter too much, right? So we're gonna add some something in the header. Okay, so the first thing I'm gonna add is a new function called start recoil recovery, and then just some flag. So this is the function that will initiate the recoil recovery itself. And this is just some flag that will tell us if we can do the recovery or not. And this is also another flag that will initially be set to true to tell us if our recoil is neutral, meaning it's not recoiling upward or recoiling downwards or recovery. All right, now we can just implement this recoil recovery function. And here, all we have to do is just set the flag to true. And you might argue that instead of just calling the function, we can just set this directly. That's true, but maybe I want to add something later on, so I decided to just make a function. Okay, so that's the start recoil recovery. We also want to add something in our fire function. So in our fire function, not only do we want to start our recoil, but before we do that, we also want to check if currently we are at recoil neutral. Because if so, then we want to save our recoil checkpoint with the new value. So get your actor or your player character and just get control rotation. And not only that, we also want to set this to false. All right, so that's in fire. And within the tick component, we also want to perform the recoil recovery. And we can do this by first, we also want to start the recoil recovery after we have finished the initial upwards recovery. So start recoil recovery, call it here, and here we want to else if and check if recoil recovery active. Then here we just start the interpolation back to the original checkpoint, right? So we also want to get the current control rotation and its weapon wielder get control rotation, and we want to get the delta. So this is like the difference between the checkpoint and our current rotation. And we want to normalize it. And we also want to check the absolute value or the absolute value of the difference between the checkpoint and the current control rotation, at least the pitch. So if the delta pitch is greater than 1, so that means the difference is quite far, right? So if the difference is quite long, then we want to do the interpolation in constant speed, and that's just interp speed is going to be 1 divided by delta time divided by 4. And you might want to tweak this number. So yeah, feel free to get to the interpolation speed that you want. But I highly recommend you to keep this operation in place, because this makes it so the interpolation has a consistent speed even if you have varying frame rates, right? So yeah, I highly recommend you do this for interpolation speed in a tick function, because most likely that's what you wanna that's the behavior that you want in most cases. So all right, and the interpolation is going to be math r inter constant 2. So we want a constant interpolation from the current rotation to the checkpoint, right? And we want to do this with the delta time within the interpolation speed that we have set, right? All right. And next thing that we have to do is we can just weapon wielder set control. Oh yeah, I can't access this directly, but I believe I have the interface for it. So if you have a character, you can just character set control rotation and set this to the new interpretation, right? This is most likely what you want to do, but since I need to use an interface, so I'm gonna do this. Execute set wielder control rotation, wielder interp rotation. So we will interpolate this in constant speed. However, if the distance is small enough, so delta rod dot pitch. So if this is within 1 to 0.1, so it's quite small, right? We want, instead of constant interpolation, we want smooth interpolation. So we just make a new interp speed, and this is a bit faster. Again, you might want to tweak this depending on what kind of game that you want to make, or maybe what kind of gun that you have. But for me, I'm just gonna hard code this for now. So over 6 and rotator interp rod is gonna be interp 2 current control rotation, the checkpoint, delta time, and interp speed. All right, and we also want to set wielder control rotation. All right. Otherwise, if the delta rod pitch is less than 0.1 f, then we can just end the recovery, right? So it doesn't have to reach like exactly 0, just less than or equal to 0.1 is enough, right? So just is recoil recovery active false, and we set this back to neutral. neutral is equal to true. All right, now we can try to run this. All right, now if we play, we should have some recoil recovery. So here, it will slowly and constantly recover to the original position, right? However, one problem that we have right now is if we try to use your mouse wherever, it's still going to interpolate as best as it can to the checkpoint, right? And the only way that it will stop is if you let it back to the original checkpoint. And of course, that's not what we want. We want it so that if the player moves the controller or the mouse, then the recovery just stops, right? So we can easily do this by moving to our character actor or our pawn, and in the look function, or the function that handles controller input. So you want to have a check here and check if the current weapon exists, right? And that it's performing the recoil recovery. So if it's performing recoil recovery, then we want to save the current rotation. And then the checkpoint and then we want to check the delta. And this is pretty similar with what we have back in the weapon component, but this we just use the normalized delta directly instead of finding the difference and then normalizing it. So it's basically the same thing here. And current rotation and the checkpoint. So once we have that, if we then check current weapon, first we check if is recoil recovery active. Actually, we don't need this. We just need to check if look axis vector. So if the Y input is less than 0, that means it's going upward. So the mouse is going upward. Then we want to immediately cancel the recovery. So current weapon is recoil recovery active is equal to false, and set this back to neutral. Neutral equal to true, and we can return early. Right now, and the reason why we want to find this delta is what if, right? Because this only cancels if the mouse is moving upward. If we move the mouse downward, we still want some recovery, because what if that downward movement is the player firing the recoil, right? We don't want to cancel it immediately. What we want to do instead is let's go to the weapon component and add new variables, and it's a boolean update recoil pitch checkpoint in next shot. I know it's a mouthful, but yeah, you can name it whatever you want. But basically, this will tell us whether or not we update our checkpoint mid shooting, right? So that's what happens. What if during firing the recoil we aim downwards and we pass below our original checkpoint? Obviously, we don't want the recovery to go back upwards, right? We want instead to just save the new checkpoint below our original checkpoint. So that's what this variable will tell us when we can do that. And here in look, what we can do instead is if no, it's not here. Actually, it's in weapon component. So in fire function, so here if b update recoil next shot, if we can update the pitch checkpoint, then we will update the pitch checkpoint, right? So recoil checkpoint becomes F rotator. We only update the pitch, so it's weapon wielder get control rotation pitch, but we want the original recoil checkpoint yaw and roll. So the only thing that we update is just the pitch, and then we can set this back to false. So, false. And now back in the original look function, we can add a condition where if when we move the mouse downward, down enough that it becomes where the delta pitch, where the pitch becomes less than 0, that means it's going downwards, right? The difference become negative. So what we want to do here is we want to tell our weapon that, hey, you can update the checkpoint for the pitch in the next shot. And we set this to true. And that's it. So now, if we try to shoot, it will recover back to the original position, right? Release it and move downwards, it's still going to go back to the original checkpoint. And but if we try to recovery and then move upward, it will stop the recovery, right? On the other hand, if we try to fire and then move below the line, it will recover. It will update the recovery checkpoint. I'm not sure if it's noticeable just from the video, but so it just updates the original from the original checkpoint to the new checkpoint. So that's the recovery for the pitch. One thing that you will immediately notice is that this only affects the pitch. So if we move it to the right, it will update itself. It will still use the original yaw checkpoint, right? Which probably is not what we want. When we shoot something and we move to the right and left, we want it to also update the yaw checkpoint, not just the pitch checkpoint. At least I want it that way. And from what I've observed in Destiny, that's also what they have. So we're going to replicate that as well.